I'd be able to share my screen.
You should be, yeah, right. Let's see.
1 second, people. So sorry.
Yeah, that's my fault.
So hopefully, can everyone see? Okay, wonderful. So I'm Erik Hoel. I'm kind of new in talking about dreams, but I got my PhD working in a sleep lab. So the person who I got my PhD under, Giulio Tononi, is the author of the synaptic homeostasis hypothesis, which is a pretty well-regarded hypothesis when it comes to sleep. Of course, all of these neuroscientific hypotheses are just that, right? We still see the brain through a glass darkly. And I used to work on theories of consciousness and published a little bit about sleep, but mostly worked on consciousness. But theories of consciousness, it turns out, are like really, really difficult. So I thought I'd try my hand at maybe some like slightly simpler fields, using maybe some of the techniques. So this is going to be a very abstract talk that's comparing different theories within the field of sleep research, particularly concerning what is the evolved purpose of sleep. Why do we sleep every night? It seems like there needs to be an answer to that because a huge number of organisms spend so much of their time doing this, and so unless it's kind of neutral evolution or something, it seems like there should be something that's selective here. So in last year, I proposed this, have been thinking about this for a while, and proposed this notion of the overfitted brain. And at first, I want to point people to a place where I'm going to articulate the ideas I'll talk about here in a much superior format, because I'm very bad at making talks, and they tend not to be nearly as good as my articles. So if you want to actually know what I think about this in detail, please go and check out the article. It was in Patterns. It's called The Overfitted Brain. And there's also a couple other sort of explainer or more general articulations of the same idea in some earlier publications, one in the New Scientist, and then one even back in 2019, I wrote a very long article called Enter the Supersensorium, which is not just about the overfitted brain hypothesis, but also about a lot of its consequences. And if you want a good commentary on the overfitted brain hypothesis, not written by me, you can also check out something that was written by Princeton Richards, which was also published in Patterns, which I think deals with it very fairly and is quite good. So broadly, why do we want a theory of dreams, right? Well, meet Bes. Bes is the Egyptian god of dreams. Bes is described as a short hermaphroditic deity, and was supposedly, I guess, kind of a comforting god. He was kind of fun, a fun god, the god of dreams. And the Egyptians used to practice trying to summon Bes in their dreams, already showing that we can manipulate dream content back in like 1350 BC. And the Egyptian ritual for summoning Bes is you make a drawing of a Bes, or also sometimes called Besa, remember, hermaphroditic, on your left hand, and enveloping your hand in a strip of black cloth that has been concentrated to Isis. And you lie down to sleep without speaking a word. And when you wind the remainder of the cloth around your neck, and you think about Bes, the Bes comes to you, right? This is actually pretty close to something we call now targeted dream incubation, which scientists have sort of rediscovered. But my point here is just that interest in dreams and dream manipulation and why we dream, which have been, within the context of mythical or spiritual practices, is extremely old. It seems very fundamental to us as humans. We also, of course, know that animals dream. So these are questions that have been with us, for a very long time. But what about the current, and when it comes to dreams, right, we have to understand that there's a rich spate of hypotheses, but they're not sort of nearly as well agreed on, even as hypotheses about why we sleep, why animals sleep. And even that is still pretty debated. But I think within like broadly why we sleep, there's a couple quite good specific hypotheses that I want to mention that are just broadly about why we sleep rather than why we dream. So first is this idea of the metabolic clearance, which is basically that your brain is generating a huge amount of garbage. Neurons generate garbage as they operate, right? These little like Maxwellian demons in terms of the ion pumps are constantly generating, molecular garbage, and that needs to get cleaned out, and it gets cleaned out during particularly slow wave activity, when these big waves of activity traverse the cortex and you're very unconscious during sleep. And that this was discovered only quite recently, that there's this system of cerebral spinal fluid that comes in and sort of flushes your brain like it's a washing machine. And there's still a little bit of question about, how real this is. But if it is real, I think that this is going to get the Nobel Prize. I think it's an amazing discovery, and you should check it out. Another, I think, quite good hypothesis about why we sleep is synaptic homeostasis hypothesis. Again, this was something that was proposed by Giulio Tononi, who I got my PhD with. And this idea, it's sort of that when you're learning, there's net synaptic potentiation, which if left unchecked, it would lead to this sort of saturation of the even ability to learn, because all your synapses would be so strong that you couldn't even learn, right? So you have to deal with this at some point, and you have to have this sort of like net reduction of synaptic weight that's sort of brain wide. And I think it's an interesting hypothesis. It's one of the rare hypotheses where you can kind of go in and directly check on it by looking at, the density of synaptic spines and so on, or dendritic spines while animals sleep. So I won't say it's been proven to be correct, but I think it's a good example hypothesis. I think there's kind of a lot less good hypotheses when it comes to dreams. Things are generally pretty vague compared to like synaptic downscaling, which is quite mechanistically specific. So let's talk a little bit about current theories of dreams and what we would want out of them. So first, what do we want out of theory of dreams? Well, we want to know their evolutionary purpose. We want to know why they were selected for. We want an explanation of their phenomenology. So dreaming, when you're dreaming, your experience of the world is very different from your waking experience. It's not totally different. It's not like you're having some other things, like you're conscious, of course, during dreams, but you are, the structure of your phenomenology is very different, right? Like you don't have as much detail, weird, very strange things are happening, and so on, right? And this is actually something that a lot of theories elide. They totally sort of shove the weirdness of dreams under the rug, and that ends up being a problem for them, as we'll get into. There's also issues around, we want to know what the biological mechanism is. So like how dreams can actually come about. And of course, we want it to fit broadly with the available evidence. So there's a lot of like dream research that's just studying generally how small numbers of people sleep, like in overnight sleep labs. And, I really admire the people doing this, but I want to point out, well, again, we're taking this really, really high level view of dream research, that dream research has all the problems of neuroscience, plus it's got some extra ones, right? So it has all the standard problems of neuroscience, which is like small sample sizes, the effects are difficult to reproduce, designs can often be fishing expeditions, there's going to be like blobology that occurs. People testing it are kind of biased in support of their research. This isn't new, and this doesn't mean that the field is junk, but these are just like pretty standard problems in neuroscience, and why you shouldn't always really go off of just one study, right? You kind of want to look at the set of studies and sort of find something that fits pretty well with the set of studies that we have. But, if there's one study with 12 people in it and it contradicts the hypothesis, we should be kind of wary of throwing everything out, because the likelihood is that everything will eventually be contradicted just because the research methods are not quite there. And then in dreaming, it's even worse, right? People are even in a worse position because there's no direct report. You have amnesia of what you've been experiencing, and the studies are limited, of course, to a single night. You have to follow people through a single night. And that means that, if dreams have some sort of cumulative effect or aren't just about, right, so you can see how the bias is, right? A lot of theories end up being about dreams are about something that happened today, right? Or that happened when you're sleeping the day before, right? well, why are dreams about that? And it's like, well, that's what we can test. We can test single nights. So we want to track people during the day and then test something at night. So that's what our hypothesis is going to be about. So I'm really not going to spend a lot of time discussing individual studies because there's a lot of them. And instead, let's sort of take a bird's eye view of the theory and just talk about the sort of theoretical constructs and fits that we have with what we want out of theories of dreams in contemporary dream research. And I want to do this overview before getting into the overfitted brain hypothesis, because I think it's really important and interesting both to differentiate it, but also to see, you know, what the cases of overlap are and where we can merge things and things like that. But I think it helps to take this overview. So roughly, hypotheses about the current nature of dreaming can be split into, you know, 5 or so camps. And there's sort of like mashups of these, but broadly, you can say dreams are maybe therefore emotional regulation, therefore some sort of memory consolidation, like consolidation of the day's memory. Dreams maybe are actually for the opposite of memory consolidation. Maybe they're for selective forgetting. Dreams are some sort of preparation for real world problems. Like dreams are basically like a simulation, and we can sort of act out solutions or so on, or agency within the simulation. And then this 5th one, which is dreams sort of benefit predictive processing. This one really kind of only makes sense within the predictive processing framework. So we'll cover that, but I kind of keep it a bit separate. So let's just go through some of these. Dreams are for emotional regulation. So perhaps dreams act like an emotional thermostat that sort of regulates your emotions. And there is like some evidence from dream journals that, you know, more emotional dreams predict better recovery from disorders like depression. But, you know, again, we have really small sample sizes and it's a lot of kind of questionable interpretations involving, you know, what counts as an emotional dream and what not. We know we've got some neuroimaging studies to back this sort of thing up. And, you know, there's some evidence that changes in sleep and REM, you know, have, you know, some correlations with mood disorders. But generally, you know, one issue with the emotional connection is that almost none of it is really specific to dreams or even REM. We now also know, by the way, that you can dream when you're in non-REM. We know this from sudden wake-up experiments, although it's definitely still mostly more associated with REM statistically. And, you know, many cognitive disorders have sleep problems. And sleep deprivation, like if, again, you can just reflect, right? Like if you've ever been sleep deprived, you do become emotionally irritable, right? And you definitely have a lack of emotional inhibition. But you also have this is true for almost everything, right? Because you have a breakdown of executive function when you're very sleepy. So it's kind of unsurprising that any sort of sleep deprivation would be related to emotional regulation. And then also, like, if we look at the phenomenology of dreams, they're not like extremely emotional. Like emotionally neutral dreams are pretty common. There may even be a slight bias towards negative affect in dreams. And also you have this problem where dreams that have a high emotional valence, like dreams that are really frightening or really pleasurable. Oops. Sorry, my screen froze for a second. You also have the problem where dreams that are like really frightening or emotional or good or nice, right, are going to be more memorable, right? So you're going to report them sort of more. But I don't think, looking at the field, that there's a lot of strong evidence that dreams are really specifically for emotional regulation. Then you have this hypothesis for dreams are for memory consolidation. And this is probably the leading contemporary theory of dreams. And it often involves sort of like computer metaphor. Maybe dreams are for some sort of storage, like they help the day's memory get stored. It's not really clear how in many of the cases, or like what it means for memories to be stored, right? But another case that's maybe more specific is when people talk about memory replay, which is this discovery that it seems as if there's some sort of replay of the day's experiences going on during sleep. But again, that hasn't been super specific to dreams. Like people see it a lot during non-REM. In fact, the original discovery was not in REM. It was in slow wave sleep, I believe. And you know, it sort of implies that dreams are somehow, you know, integrating these memories. But again, the implication is that the dreams are sort of an epiphenomenon. The dreams are some sort of like byproduct of this consolidation process, and it's really not clear what this consolidation process is exactly. And you know, just to pick on like a more specific version of this that I'm not sure if anyone like really seriously promotes, but it's like something like dreams are like replaying the day's memories or something like that. So first is, I don't actually think there's any theoretical reason why replaying memories would help them, because you lack baseline truth, right? So replays might actually introduce errors, and actually there's a lot of memory research showing that when you remember something, you reinterpret it. And also, you know, dreams just aren't replays. They're just not a replaying of the day's events. It's very rare for that to happen. And when you look down at the replay results, what you actually find, despite this sort of trumpeting as being replays of memories, is that the vast majority of supposed replays are never before seen firing patterns. So they're things that like if it's a mouse running a maze and there's grid cells, you would see some firing pattern grid cells that you've never seen before, and then that would still be counted as replay. So I'm kind of like, I haven't seen a really great mechanism for sort of memory consolidation proposed. Like there could be some, but the most specific ones, which are some form of replay, don't seem to fit well with dream phenomenology.
I'll just jump in very fast. It seems like you have some interference on your microphone. It sounds like it's jumping into something, or yeah.
Is this better?
I think so.
Okay, yeah, so sorry about that.
Perfect.
Okay, so the other option is that maybe here's another hypothesis, right? This is actually an older hypothesis, and I like this one particularly because it was originally proposed by Francis Crick as one of the co-authors, and they have this notion of reverse learning, and the notion is that dreams are somehow helping the brain unlearn. And I think that that's quite a clever idea, because it gets to the fact that dreams don't seem to have like the opposite purpose. Like you wouldn't want to learn from dreams, right? So it seems like this intuition is correct, but the implementation that they propose, I don't think really makes any sense. So you know, first of all, we don't dream about the things that we forget. Certainly there doesn't seem to be any strong evidence of that. And this, you know, in the various reinterpretations that people have given this when they've tried to implement it specifically, like some people have taken this idea and tried to implement it in neural networks or things like that, it almost always requires some sort of change in the learning rule, in that like synapses are basically doing the opposite during dreams that they would do when you're awake. And that sort of biological switch, we'll see it impacts some other theories, like the wake-sleep cycle, which is an algorithm that does something almost kind of similar. That also requires a change in the learning rule. There's just no good biological evidence that we have this huge change switch in the learning rule where, like, STP and STD like just get reversed or something, or LTP and LTD. Sorry. So the other kind of theory is that maybe, our third theory is that maybe dreams are somehow preparations for real world problems. So this is sort of well known, right? Like you have this notion of a correlation between creativity and dreams. So maybe the fact that sometimes people wake up and they've solved something that they haven't thought about before, or they've been thinking about for a long time, and suddenly they're presented with a solution. Maybe that has something to do with this. Or maybe with dreams you sort of act out things you could never do in life, right? Like you can jump off buildings or so on. I'm going to group a couple hypotheses under here that people might disagree with, but I think that this is a pretty broad umbrella. So, for example, like next up theory, which is this network exploration to understand possibilities. It's a bit of a mashup between some of the other types, but it's true that dreams certainly simulate the world, right? But it simulates the weirdest world possible. And so I think that what dreams as preparations for real world problems needs to answer is, why would we be examining the most unrealistic and unnatural and unlikely possibilities? So if dreams are some sort of simulation, any strategy that you have that works in a dream is never going to work in real life. So it's like you're being chased by a monster. So you go upstairs into your childhood bedroom, which is becoming a spaceship, and you manage to get to the controls, and then the monster you realize is actually your mother, right? And so this is not like a viable strategy that you're going to go out and employ in the world. In fact, if you actually learned and implemented any procedures or strategies from dreams and implemented them as an evolved organism, you'd be jumping off cliffs. Right, so it seems like this sort of simulation hypothesis needs to really address why it would be that our simulations are like so bad, they're so unworld-like. Okay, then there's this kind of fifth, almost like totally siloed area of dream research, which is all about dreams and predictive processing. So for those who don't know, predictive processing is a hypothesis that essentially the brain is constantly generating predictions about what's going to happen, and then it sort of is judging sensory input in this bottom-up fashion where it's comparing the sensory input to its predictions, and its overall goal is some sort of minimization over those predictions. You might measure that with something like the free energy, and the whole idea is that the brain just wants to be constantly improving its predictions about its own future states. It's a very popular lens in neuroscience, particularly cognitive neuroscience. There's definitely no consensus that the brain primarily works on a predictive processing basis, right? So we should be a bit wary of, theories that sort of assume a predictive processing framework, because of course, if something goes wrong within what you've assumed, then your theory kind of won't make very much sense. So it's kind of unclear that the cortex actually functions primarily to generate predictions about its own future states. And then again, it's sort of these sort of things run into the same issues that the dreams are for solving real world problem group has, right? Which is that dreams just don't seem very good candidates for minimizing surprise, right? It seems as if dreams are like really sort of bad playgrounds for predictions. They're bad playgrounds for causal agency, where actions are tested against their outcomes. Like some of these predictive processing frameworks are like, well, you can act in a dream and you can see what your action is going to do, and then sort of judge that. And it's like, again, none of the actions you take in dreams are really gonna have a significant, sensible sort of impact that you're going to be able to make good long-term decisions off of. So what's mostly missing from these hypotheses? And I think that what's mostly missing, and I realize I've blazed through them, right? I'm sure the proponents of these would be like, this is a really high-level sketch, and there's all sorts of important details you're missing and so on. But I think like generally what I would say that these theories are missing is an explanation of the phenomenology, that the actual conscious experience of dreams and what that experience is like, and why it's different from wake. They do pretty good on the purpose and the mechanism, and most of them actually, most of them aren't immensely contradicted by a bunch of evidence, but they just don't really pay a lot of attention to the actual structure of dreams. Dreams are some sort of epiphenomenon, or it's like only some small percentage of dreams seems to fit fit what they think the purpose of dreams would be, some vanishingly small percentage. So I think we have to take very seriously the notion that the purposes of ideas are the dreams themselves, right? So sorry. So like, there has to be a reason for this very strange state of experience. Okay, so what is the phenomenology of dreams? I keep saying they don't fit it, but I'm not defining what I mean by phenomenology. Okay, so in dreams, dreams are pretty brief. There's many different scenarios. Dreams are sparse, so they're not as rich in conscious detail as your regular waking experience. That's because it's entirely generated by your brain. A very good example of this is that you almost never read in a dream. You can see big text like stop signs, but it's very rare. Like even your phone, right? Like how much time you spend on your phone every day, right? But looking at your phone doesn't really crop up in dreams because the text detail is too fine grained, right? So you can't, your simulation when you're dreaming is like some sort of, dropped out coarse grained version of your waking experience. It's very strange or hallucinatory. So the term dreamlike, right? We all sort of know what that term refers to, some sort of Lynchian aspect of dreams, and things are very category breaking, which is why actually it's quite nice that Bes, the Egyptian god, is hermaphroditic, right? Like it's very sort of dreamlike, category breaking notion where people can become other people, places can become other places, and so on in dreams. And we have this the famous opening sentence of Kafka, and of course that notion of Kafkaesque is a very good definition of dreamlike, and that story begins with someone waking from uneasy dreams, right? So it's a dream that's sort of an extension of dreams. So we can sort of rephrase the question, like, why would evolution, just specifically focusing on the phenomenology of dreams, why would evolution endow us with an inner Kafka? And I think that the answer has to be, or very well could be, something that looks almost at first paradoxical, right? Because this is what dreams have to address. Kafka, a short story by Borges or so on is going to be fantastical and strange and very unlifelike. So you have to have some good reason why experiencing unlifelike things would be somehow important for learning or important for your brain in some way. And if you look around, I think that there is a very clear sort of analogy or example that's going on right now in deep learning, which is that the phenomenology of dreams looks a lot like data augmentation techniques common in deep learning. And these data augmentation techniques take data that a deep neural network is learning, and instead of just training them on the data, they change the data in some way. Like very common examples are dropout, which is when you're basically dropping out parts of the data, or you're dropping out parts of the network, but those are kind of mathematically very similar. Or you get something like domain randomization, where you're sort of tweaking some aspect of the data. An example would be like for a self-driving car, if the video was being shown, imagine that suddenly everything is hued red, right? Like everything is red that the self-driving car is seeing, right? So that would be an example of domain randomization. And I think this is worth pointing out because we forget how recent deep learning is. I mean, I forget when Go was sort of conquered, but I think it was 2000, might have been 2016, it definitely was like 2015. So very recently, right? Very, very recently, last 6-7 years, these things actually took off and were actually capable of beating humans at very complex tasks. And they're still the only things that do so, right? So there is nothing else on Earth that can beat humans at complex cognitive tasks other than deep neural networks. This is just a fact. So neuroscience should take very seriously looking at these as model systems, particularly because they were originally inspired by the brain to begin with, right? So we have a nice sort of self-circular loop. And, as they get very big, deep neural networks evolve a lot of brain-like connectivity. So they develop representational properties. They develop things that look a lot like grid cells or shape tuning. They even are subject to visual illusions that look similar to ours, right? So we should take very seriously that these things are not perfect models of brain activity by any means. There's a huge gap between the biological reality and these sort of digital representations. But we should take seriously at least that the fundamental problems that these systems run into are fundamental problems that we ourselves would face as evolved organisms. And this is where the data augmentation comes in, because it's used to address these ubiquitous issues of learning in deep neural networks. So the overlap between the brain and what deep neural networks face, particularly in learning, I think probably overlaps significantly. And one particularly ubiquitous challenge that you can't really get around, except in some rare edge cases, but like generally you can't get around this problem, is that deep neural networks face this trade-off between generalization and memorization, which is that when they're training, when they're learning a data set, you want to stop their learning at some point too early. If you want to stop it early, because if you let them keep going, they'll eventually overfit. And what overfitting means is just that you are dedicated to getting very good at some particular task over some particular limited data set, and that what's going to happen is that you're going to train yourself too well, and you'll become too specialized to the sort of quirks or vagaries of the data set that you're being trained on. And this is an omnipresent problem, and it's very difficult to get around it. But there's sort of a bag of tricks that artificial intelligence researchers use, and these come mostly, like some of the most common are this notion of like a corrupted input. So you take the self-driving car, and you would be doing essentially the equivalent of like placing, black bars across, at various intersections or so on of the video that it's learning from. And that would force it to sort of generalize and take a step back and be like, okay, I don't want to overtrain too much on the specifics, because suddenly I'm being trained on something where there's this corrupted data, and the corruption is sort of combating the quirkiness or bias of the data set, right? And the more self-similar and biased your sampling is, the more overfitting will be an issue, right? So this seems like this sort of overtraining / undersampling is something that an organism can't really get out of. One, because your experiences, I mean, even for us, right, as humans, every day, they can be highly self-similar and biased, right? They can be a real serious subsampling of your overall environment. And then in organisms, it's actually even worse, which is something I haven't really seen pointed out, but it's far worse in organisms, right? Because you can't turn learning off. In deep neural networks, you can just, you finish your training at some point, and then you go and you deploy the network, right? Well, that stage never occurs in mammals, right? We're never finished and then we're deployed, right? We are constantly learning. You're learning even when you watch bad TV. You can't turn it off. You're learning the same amount when you watch bad TV as you are when you're, taking a math class, right? Like nothing, special is happening in your brain when you're taking the math class, where it's like, oh, now there's learning, right? It's always learning. So it seems likely that this is a really serious problem that organisms would face, and they would need some way to combat overfitting, overtraining, and keep sort of generalized performance, and keep the brain from getting too specifically focused on just some small number of tasks. And if so, then it seems like maybe dreams are the biological equivalent of data augmentation. They're hallucinogenic, and they look, again, a lot like some of these techniques that people use. And the fact that they're hallucinogenic, category breaking, and fabulous means that they're always very different from the training set. Like whatever your training set is as an organism, these dreams are going to be very different from that. So you're forced to learn something in this sort of imaginary world that's extremely different. You're forced to experience these extremely different, weird things. And this is going to combat your natural tendency to get more and more focused and more specialized all the time, which seems like it's this unavoidable problem of learning, given that you can't like perfectly sample the world. And the thing I like about this hypothesis, which is that brains are always kind of in danger of overfitting or danger of overtraining, is that it explains the phenomenology of dreams quite well, right? So the sparseness of dreams is coming from this sort of bottom-up dropout. Their hallucinatory nature is coming from certainly their stochastic origin, but their notion of being this sort of corrupted input. And the narrative nature of dreams is from the fact that these are things generated by your brain. Your brain is like a filter, right? So if you just inject noise into your brain, you'll get non-noise out of it, right? The idea is that the distinct phenomenology of dreams is sort of specifically balanced. It's similar enough to our waking life, but different enough that it's relevant, but different enough that you are being exposed to this out of sample distribution, that's sort of out of distribution stimuli that you wouldn't normally get during waking life, that's going to keep you from becoming overfitted and overtrained and overspecialized, and eventually your performance suffering as a consequence of that, your performance on various tasks. Okay, so we have, I think the OBH fits well with a couple of these theories, sorry, with a couple of what we want out of a theory, but, you know, is it fit with the available evidence? I think like broadly, yes, it fits with the available evidence. I mean, at least as good as it seems like other theories do. You know, a great example of this is that it remains the case. This is something I think originally put forth by Stickgold, that, you know, one of the most effective ways of actually triggering dreams is that contain any sort of similarity to real life is repetitive overtraining. So examples include like playing extensive games of something like Tetris or a ski simulator, and then people might report that they dream about Tetris or dream about skiing in the ski simulator the next night, although they don't report that they replay the actual memories of the Tetris or dreams, that they're playing some sort of dreamlike Tetris or dreamlike ski. And so it seems, you know, quite likely that, you know, if we think about it as this overfitting as this thing that the brain constantly has to sort of stay on top of, and it's basically a homeostatic component, right? So, you know, I've referred to this as sort of cognitive homeostasis, right? It's like you need to keep your mental models and your cognitive performance sort of fit, and so you have to trigger dreaming, and of course, you know, in cases where you're really overtraining on something, you might trigger specific dreams about something. But in general, you're not dreaming about the day's events. They're just things that are there to sort of keep you from getting overfitted. And by the way, the OBH in this sense also can, you know, account pretty well for these statistical replay results, because again, most of these are never before seen firing patterns. So that would certainly explain why you would want to do a bunch of never before seen firing patterns if your goal was like memory consolidation. There's some other things that I think are maybe the OBH is uniquely positioned to explain. So like word association tests, you know, things like that are pure memorization don't seem to benefit as well overnight sleep. It's more like generalized cognitive ability that benefits the most. So like learning a list of random numbers, sleep seems to help, but doing math problems, sleep seems to help more, right? So again, this notion of the cognitive homeostasis, it seems to be better than just like pure memorization, pure learning in the traditional sense of like learning, you know, a rote learning. And there's even evidence, I think, of overtraining on humans. You know, if you really, people often report this personally, like if they start playing a new video game or something like that, you know, they'll kind of reach a plateau, and to get past the plateau, you'll need to sleep, right? So you'll get better at something, and then you'll need to sleep, and then you'll be even better at it, and you'll kind of break past your plateau. A lot of people will report that. There's some scientific evidence to back that. The OBH, I think, does a very good job explaining why that would be. But what would like actual experimental validation of a hypothesis like this look like? Well, it would be very, very tough, to be totally honest. There's a couple ways to do it. I want to point out one thing, which is that it could very well be the case that the effect of dreaming, and this doesn't just apply to the OBH, but I don't really see this talked about. It could be that the effect of dreaming is cumulative. So it's not over a single night. And if it's not over a single night, then you have a real problem, because in neuroscience, you know, all the labs and the studies, they study stuff mostly over single nights. And I've always suspected, and I think the OBH would say this directly, that the effects of dreams would be rather cumulative over a lifetime, right? So it's just keeping you in cognitive homeostasis. And also, it may be the case that eventually your mental models of the world, your performance is so good, you've actually sampled enough of the world that you really don't even need dreams that much anymore. Certainly, as you get older, you sleep a lot less. So anything that's like, you know, you really need dreams to integrate the day's memories into the next day or something like that, it's like, well, when you're, you know, 60 or 70 or so on, what you'll report is sleeping, you know, a lot less. And, you know, time spent dreaming goes down, you know, and so on. And so it's just very possible that, you know, these people just aren't dreaming and yet are sort of cognitively okay. Yeah, they might be at greater risk for dementia or so on, but they're basically cognitively fine and totally competent. They're not like, you know, amnesic about the previous day. And that might just be that after 70 years of dreaming, you just don't really need to dream that much more to keep yourself sort of well fitted. Like you're getting not very much return, not very much bang for your buck. But you could try to test it in a couple of ways. which is you could test for generalization performance as separate from pure memorization. As I mentioned, there's already some results, but you could kind of do this a lot more rigorously. You could look into something that I like to call dream substitutions, which I think is an interesting idea, which would be that maybe you can get the benefit of dreams when you're awake. Because again, if the purpose of dreams is the dreams themselves, then imbibing dreamlike stimuli should have some of the benefits of actual dreams. And then, are dreamlike stimuli especially helpful to deep neural networks? So in other words, could people in the field of deep learning, could they take away that, yes, you could do dropout, you can do domain randomization, but really like the best thing to do in the most ideal sense would be to help with overfitting, would be something kind of dreamlike. And the more dreamlike you sort of make something, the more it helps with overfitting. I think that would actually, even though that's just in deep learning, it's not even in real brains, I think something like that would actually be pretty supportive of the OBH. And then I want to talk very briefly about some highly speculative consequences of this, which goes back to this notion of dream substitutions. So I grew up in an independent bookstore. I grew up selling books and loving books, but I've always been sort of puzzled as to why humans love fictions, why humans care about what happens to Harry Potter. Harry Potter is not real. Hogwarts is a lie. Every fact about Hogwarts is incorrect. And I think it's totally imaginable that a race of aliens would land who are like hyper realists, who only care about real facts and real things, and have no, understanding or sympathy for our absolute love of lies, which is what fictions are. But to sort of counter that, maybe they would be sympathetic because they would recognize that these fictions are acting as these sort of out of distribution stimuli, much like dreams, in that they're sort of artificial dreams. And there's a very famous theory about how humans got so smart. And one reason we're so smart is because we can cook our food, which means that we don't have to have as big of a digestive system. Humans' digestive systems are tiny compared to other animals. And the reason why is because we're pre-digesting our food using fire. And maybe fictions are just like we've sort of outsourced our digestive systems to cooking. Maybe we've outsourced a lot of our cognitive homeostasis to artists, and that a lot of the fictions that we imbibe, despite sort of looking like a waste of time and so on, are actually helping with our sort of cognitive homeostasis. They're helping keep our mental models fit and our performance good because they're constantly allowing us to sample things that are out of our normal day-to-day experience. And I talk about this, again, highly speculative notion in a couple places, because I think it sort of underlies this very interesting kind of radical notion that you can maybe have something like that looks like a scientific explanation of art. If you want to know more about that specifically, rather than just the details of the OBH, you can look at something called Enter the Supersensorium, which is an essay, really long essay in the Baffler about this, and then also in Salon, there's another essay that's also takes this angle. So again, that's quite speculative, but I think of interest to people. If you want to actually get the full view of this stuff, please do check out the original article. I'm aware my I'm just not very good at giving talks, and I never have like impressive or interesting slides or so on, right? But hopefully the ideas were interesting, and I really appreciate everyone sticking around through my technical problems and weird noise of my fan. So much appreciated, everyone. And I'll take questions now.
Yeah. Thank you so much for your great talk, Erik. It was a lot of good information and a good explanation for your theory. So we have a lot of questions actually, but we have very limited time for how many we can take. So if you stick around for the panel discussion later, then it's another chance to ask questions that might not be answered. So I'll just start at the top here of the Q&A. So does emotional regulation theory cover both positive and negative regulatory roles? For example, does nightmare disturb emotional regulation and an opposite reaction to a sweet dream?
Yeah, I don't want to speak too much because there are people who, are going to be much better proponents of that theory than I would be. So I don't want to like speak for them. So don't assume that my explanation is theirs at all. But I would just say that that's a good, like my understanding would be that essentially both are good, right? Because they both somehow have a positive effect, where like the nightmare, it's like exposure therapy, right? And then the positive dream is just nice because it's positive. And I think that that's sort of like, it's good for in both cases. One should be maybe like a little bit leery of. But again, I'd check out someone who's more of a direct proponent of those theories. And there's been a number of papers published on it.
Thank you. So the next question is perhaps a little bit more targeted or to the OBH. What would you say about how would you explain that some patients dream during quote pathological sleep, for example, anesthesia? Is the brain using the opportunity to disrupt overfitting in this case?
Yeah, so I actually don't think it's a massive mystery, like the biological mechanism of sleep, because this is really a question about the biological mechanism of like, why is this occurring during anesthesia? Well, it's occurring during anesthesia because anesthesia is putting the brain, or at least certain forms of anesthesia, right? Certain forms of anesthesia, you really often don't dream. So this depends on the mechanisms of the anesthesia. But, so some of these anesthesias are putting the brain in a very similar, both neuromodulatory milieu, but also sort of mechanical structure, like dreams, where your bottom-up input has been severed. The only thing left is sort of the mind-wandering internal dynamics. And I always think it's sort of like unsurprising that you would have dreams given that scenario. Like if you cut off bottom-up input and you just allow for internal activity, to me, it's actually somewhat unsurprising that you end up with dreams, because of course, even if you filter noise into the brain, you'll end up interpreting it as something, because this exact same thing happens with, if you know about like Google Deep Dream, right? Why does Google Deep Dream generate these images? Well, it's because you feed noise into the artificial neural network, and the output is some sort of weird amalgamation of the stuff it's been trained on. So this seems very likely that this is sort of how dreams are being generated. And I would imagine it's just that the biomechanical sort of structure is identical, or at least similar enough, in whatever this particular anesthesia is. And like maybe you could think of it as the brain taking the opportunity, but I think it's more like it's just in a particular neuromodulatory milieu, dreams will occur. The question really is like, why do we set aside time every day under normal circumstances to make sure that condition occurs? If that makes sense as an answer to that question.
I think it was a good answer, at least, but I won't speak for the one who asked the question. So next one is broadly related to the substitutes of dreams. I wonder versus REM sleep dream, cognitive phenomena such as mind wandering, inner speech, thoughts, daydreaming, if they can have the same benefits as dreaming occurring according to the OBH.
Yeah, it's a really interesting question. There are some aspects of mind wandering which do overlap a lot with dreaming, and particularly dreaming often starts out as a form of mind wandering, right? Like we can all speak to that experience, and of course people have sort of tracked that down in the lab. It's not all the time, but a lot of the time it starts off as some form of mind wandering. So I think it's possible, but I also think that it seems that it seems that with mind wandering, the real advantage is that you can sort of take different paths into different problems. Like I'm not sure how much time a dog spends mind wandering, but I'm sure that they spend a lot of time dreaming, right? If you've owned a dog, you've seen it dream, right? So my suspicion is that mind wandering is some sort of like unique linguistic aspect to humans, where that really only occurs with us. It's hard to imagine other sort of animals mind wandering too much. Maybe they do to some degree, right? But yeah.
Related to that, the question of my own. Would you say that or suspect that the brain does or does not have a kind of self-monitoring of how much it has kind of tried to avoid overfitting. So let's say you spend a whole day mind wandering or reading books or doing other things that kind of would avoid overfitting. Would you, I don't know if there's done research on this, but if you would still kind of have as much REM sleep the night after, kind of also related to your comment about how as we get older, we dream less or have less, sleep less at least. So could one perhaps then avoid dreaming as much or sleeping as much by avoiding overfitting during the day?
Yeah, so this is very much like the notion of a dream substitution, right? Like to me, I mean, I think the ideal case would be you do something like a VR goggles and you do like a VR dream-like experience, you know, to like very tired people, and you see if maybe it can recover some of their cognitive abilities. Again, you know, the issue with this is, let's say we don't see an effect. Well, maybe that's because the individual days and nights just don't really matter that much. Like, again, maybe dreaming is this really cumulative thing. But there's some evidence that the individual nights might matter. And that comes in this notion that during overtraining, you can get dreams about particular things, particularly your gaze events, right? So your gaze events can bleed into dreams, but they seem to only bleed into your dreams when like either very, very serious things happen where you're paying a lot of attention, or you're sort of overtraining. So it seems as if when there's massive learning that's occurred, that's when you can see the sort of you see the day's activity reflecting your dreams. So that probably does indicate that it's not really that there's something assessing the overfitting of every region. I would really doubt that sort of top-down sort of tracking. I don't know how it would be accomplished, but more like regions that have undergone a lot of plasticity, or really important like memories or performances or brain modules, or exactly however you want to sort of carve it up. When they are under a huge amount of change, then that might show up more almost naturally through whatever the process is. So that's a little bit more what I would expect, but yeah, in general. And, you know, people have done some, you know, correlational studies where they look at like neuroimaging activation of areas during sleep versus training during the day. And they do see some, you know, broad scale correlation, stuff like that. And the OBH, I think, fits fine with that.
So we won't have time for many more questions, but there's one question that has at least a common theme among some other questions. So what about the learning from the content of the dream itself? So not consolidation or learning of daily activities or using it as a simulator, but learning from the dream itself. And kind of related to that, you mentioned how the absurdity of dreams makes it unlikely that they work as a training for future scenarios. But do you know if there's any research, if this was the case in early humanity, or maybe more primitive tribes that have not been involved in modern civilization and everything going on there?
Yeah, so I don't know of anything that has studied dreams in that context specifically. Also because, I mean, there are unfortunately basically no untouched, you know, communities anymore, right? So every anthropologist has their own favorite representation of what, you know, ancient humanity was like, and you can sort of pick and choose between, you know, the extremely violent to the most peaceful, right? But you know, I would say so in the OBH, like, you are experiencing the dreams, and those dreams are having an impact on your synapses. Like, your synapses are changing, you're learning under those dreams, during those dreams, and what you're learning is the dream, right? Just like when you're in your waking life, what you're learning is the experience of your waking life. But the difference would be that in the OBH, it's not that you're learning something that's going to get utilized. You're not learning some skill or idea or strategy or behavior that's going to then be expressed in your waking life. Instead, it's just that from sampling from this very strange, very non-like waking life activity and spending some time on it, you're actually going to improve your performance when you wake up, which is almost like paradoxical. You wouldn't really expect it. You wouldn't really sort of expect it a priori. You would sort of only expect it if you spent a while thinking about memorization versus generalization and these trade-offs that artificial neural networks have. So it would sort of be unsurprising another nice thing I think about the OBH is that it sort of makes it unsurprising why we would be a bit befuddled when it comes to dreams, because this effect of you improve your performance by learning in a weird, worse environment is very paradoxical, right? Like you wouldn't really armchair reason your way into it without sort of the metaphor of what's going on in deep learning and how ubiquitous this problem of overtraining and overfitting ends up being.
Right, but could you then learn from the experience, even if it's not a realistic experience or have any value in that way? But could you take the whole experience and learn from it some lesson or something that's kind of like a moral movie or something like this?
Well, I think, yeah. So I think that there's obviously, I mean, one I think theory is just in this notion of reinterpretation, right? So like dreams might be commands from the gods, or they might be, some signal from your subconscious to get your act together, right? So there's all sorts of sort of interpretations, but like my guess is that, I mean, the way I think about this is just that, listen, it seems like, again, dogs dream. So I don't think dogs do that. I don't think they're reinterpreting, their life's purpose based off of some dream they had. I think they're just dreaming about running in weird shapes in the dark, and their master is calling them, but they can't find their master, and like stuff like that. Like, so that's what I think dogs dream about. And and my guess is their dreams are actually slightly weird, like humans are, right? Like they might confront a beast it's not like a particular wolf, right? It's like it's just like a big beast in the dark, right? It could be anything. And that's extremely, I think, dreamlike in what they're going through. And so I think they probably do have some of this fabulous, fantastical aspect to it, but I don't think they're reinterpreting it. And I think that if we have an explanation for dreams, it should be based on the fact that it's shared across a lot of animals. But not to say that you can't do any of that, but it's just that I don't think that that's the evolved selective purpose for dreams.
Thank you so much. That's all we had time for right now, but I would like to remind everyone that we're starting up again in about 10 minutes, but we're using a different Zoom room or Zoom link, so it's posted in the chat right now. So we'll start in 8 minutes from now, and the Zoom room will open in about 5 minutes. So I invite everyone to join over there, and if your question was not answered, please put it in the Q&A there, and you can get a second chance for a whole panel to discuss your question. So with that, I thank you, Erik, for your time and for your presentation, and I hope to see everyone soon.
All right, thank you so
and
much.
Also, Erik will, of course, join us in the panel discussion. So, yeah.
Thank you very much. Great talk, Erik.
Thank